Have you ever looked up at the night sky? You see the moon, you see the stars. You might even see a planet or two shining like a tiny, steady beacon. Everything seems so peaceful up there, so calm, so very, very still. But this stillness is a grand illusion. The universe is a place of incredible violence and energy. Stars are born in fiery explosions. Galaxies collide in slow, cosmic dances that last for billions of years. Black holes devour everything that gets too close, even light itself. It is a very busy, very active, and very energetic place. So a question might pop into your head. Why doesn't it all just fly apart? The universe is governed by a set of fundamental forces. There are 4 of these fundamental forces that we know of. They are gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. You are already very familiar with 2 of these forces. The first one is gravity. It is the force that pulls you down towards the Earth. It is what keeps the moon in orbit around our planet. It keeps the Earth in orbit around the sun. The second force you know is electromagnetism. Right now, as you sit there, you are a perfect example of these forces in balance. The atoms that make up your chair are made of a positive nucleus surrounded by a cloud of negative electrons. As gravity pushes you down into the chair, the electron clouds of your atoms get very close to the electron clouds of the chair's atoms. This electromagnetic repulsion is what pushes back against gravity, creating the feeling of solidity. Now let's zoom out. Let's leave the scale of handheld objects behind and think about something much, much bigger. Our home, the planet Earth. Earth is this gigantic sphere of rock and iron, more than 12,000 kilometers in diameter. The weak pull of gravity from every single particle in the Earth adds up to create this immense crushing force. That's actually why planets are round. Gravity pulls equally in all directions toward the center of mass. A galaxy, like our Milky Way, is this colossal collection of hundreds of billions of stars, along with vast clouds of gas and dust. Our Milky Way is part of a small collection of about 50 galaxies called the Local Group. Our nearest large neighbor, the Andromeda Galaxy, is actually moving towards us, not away. In about 4.5 billion years, our 2 galaxies are destined to collide and merge. This is the universe we see today. It's not a uniform explosion, but a magnificent structure known as the cosmic web. Gravity has pulled matter together into gravitationally bound structures, planets, stars, galaxies, and even clusters of galaxies. But between these filaments lie vast, empty voids where cosmic expansion is the dominant force. The universe is stable on local scales because gravity and the other forces are strong, but it's expanding on the largest scales. So in the late 1990s, 2 separate teams of astronomers set out to measure this cosmic slowdown. They used these really powerful telescopes to look at very distant supernovae, exploding stars that act as standard candles. But when the results finally came in, they were honestly shocking. The data just didn't make any sense. The expansion of the universe is accelerating. It's actually getting faster and faster over time. Scientists gave this mysterious something a name: dark energy. It is dark because we cannot see it. We cannot detect it directly. The leading idea is that dark energy is a property of space itself. As the universe expands and more space is created, more of this energy is also created. A whopping 70% of the universe appears to be this strange, accelerating dark energy. It points towards a future that is much colder, darker, and lonelier. The answer we have discovered is not a single force, but a delicate and intricate cosmic ballet. It is a story of 4 fundamental forces, each playing a crucial role on its own specific scale. From the initial fiery moments of the Big Bang, through the formation of the first atoms, the birth of stars that forged heavy elements in their cores. We are quite literally the children of these cosmic forces, assembled from stardust and held together by their delicate and persistent dance. The next time you look up at the peaceful stillness of the night sky, remember the incredible, violent, and exquisitely balanced drama that is playing out on every scale. There are new forces, new particles, and new principles of physics waiting to be discovered. Our universe is not a chaotic explosion, but a finely tuned symphony. It is a place of deep mystery and profound elegance. And in that balance, in that tension between togetherness and separation, lies the enduring wonder of our stable and very special home in the cosmos.